So I'm Roland, and I work with some students from UCSC, and we're all concerned about climate change, and we want to find out how climate change is affecting people in Santa Cruz. And would you tell us your name and how you got here?
I'm John Kennedy. I'm a private well owner. I live in SoCal. I've lived here for a long time, and about a year ago I got bitten by the bug about the concern for the groundwater issues and the saltwater intrusion, and I've been dialoguing with some of the committees and the SoCal board, water board, and I'm involved in helping thinking about planning a new groundwater sustainability agency here. So,
thank you.
And I'm Bruce Daniels. I have a PhD in hydroclimatology, which is the science of how climate change impacts water. I got that at UC Santa Cruz. And I'm also the president of the board of directors of SoCal Creek Water District.
Okay.
And I as well am concerned about climate and water issues here.
And so when you heard about our focus, how Santa Cruz is affected by climate change, what was your response?
Well, it's about time that there are things that are happening. In particular, there are things happening with this drought that we have right now today. It's probably not caused by it, but it's certainly made a lot worse by climate change. It's very different from any drought we've had in the past.
Can you explain that a little bit? How is it
Sure.
made different?
Well, some of the ways it's different. Last year, some scientists wrote a paper that said the drought last year was the worst in 1,200 years. In January of this year, we got zero rain. That's the wettest month of the entire year. And
Normally.
we in San Francisco and Sacramento got no rain, and that broke the record set last year. As you know, the governor went up to the Sierras with the reporters, and they found a field there where normally they go and measure the depth of snow. About 6 foot usually is the average, and there was no snow to be found at all, and that broke the record set last year. And so, these kinds of serious things are making it clear that, this is extraordinary. And in fact, there's been papers that show that the cause of this drought, the high pressure system that's sitting out in the Pacific Ocean, is a consequence of having less ice up in the Arctic. And that's exactly what we've been seeing in the last 10 years, is the Arctic ice disappearing.
So Bruce, it's not just 1 year of drought, though. You said it broke the record from last year. So last year was also
A record
very
breaker.
low. But how many years have we had that, going back a few years? Because it seems like we've had low rainfall quite a bit.
So I have a graph that shows that, in the last 120 years, we've had about 9 droughts. And that's about 30% of the time we have a dry year. And in the last 15 years, 11 of those years have been dry. That's more like 70% dry. So that's drastically drier than we've seen it in the last 120 years. And again, that's another consequence of climate change grabbing hold of this drought and making it much worse than anything we've seen.
And can you go a little bit more into the details? What does it do to the water supply that we have if there is so much heat?
Well, heat's an interesting aspect about it. I mean, a drought just means that you don't have as much rainfall.
Yeah.
But even if you have normal rainfall,
Yeah.
the fact that, global warming, the heat is going to increase, climate change. Every degree of increase of the temperature, and we've currently had about 1.5 degrees here in the last century, every degree of increase means that evaporation increases by 4%. So the prediction is that we'll go from a high here, a normal high of 70 degrees, to a high of 77 degrees. That's a 7-degree increase in the next century. And that means a 7-degree increase is about 10% increase in temperature, and that will produce a 30% increase in evaporation. So even if you get normal rainfall, much more of it's going to just evaporate and go away. So the amount we have for water supply will decrease as a result. The amount we have for the fish will decrease. The amount we have to push the saltwater intrusion out will decrease. So it'll make the challenge much more difficult just to maintain the situation as poor as it is right now.
So you mentioned saltwater intrusion. Can you explain that a little?
Well, I do have a map for that. Well, this shows the saltwater intrusion in Pajaro Valley. This hatched area here is all affected by saltwater intrusion, such that ocean seawater is actually gone inland. And now if you put a well there, you would find saltwater there. And we have saltwater intrusion in our area as well. We have saltwater intrusion to the eastern portion of the water district in La Selva and Seascape. And then the city, with its Belts wells in Live Oak, has saltwater intrusion there. So there's saltwater intrusion to the east of us, there's saltwater intrusion to the west of us. And those two combined means that we're kind of surrounded and it's gradually creeping up on us. So it's not as bad as it is down in Pajaro yet, but if we don't do anything, it will get that bad.
And
So what's holding the saltwater back is our groundwater.
Yeah, that's right. You need to have basically the current water pushing the salt water back out, and if you don't, it just creeps inland, and eventually it poisons the wells. I mean, literally, it's pollution, because once the salt gets into the wells, you can't drink it anymore. You certainly can't use it for irrigation. It just becomes unusable. So
And where do we get the groundwater? How do we get more groundwater back to keep the salt water?
well, all the groundwater we get comes from the rain. It falls on the ground. As I was mentioning already, a good chunk of what we get in rain evaporates. Something like 66% of the rain we get evaporates, which means that the amount we have left over to keep the fish alive, to drink and bathe and so forth, and to keep the saltwater intrusion out, that's relatively small. So if you talk about making this increase by 30%, it means that the amount you're going to have left over is much, much less, which makes the problem challenging even to stay as poor as the situation is right now. And we need it to get better than the situation right now, not to even stay equal. We need it to get better. So
So a point about this is that in Mid-County, we only have groundwater, whereas Santa Cruz City has river water to get their water from for drinking purposes. In all the Mid-County here, which is from 41st Avenue down to La Selva Beach and up into the mountains, the only water we have is groundwater. So if we don't get enough rain to replenish the groundwater, then we're just mining the groundwater and it's going away, and we're running out of water, and we have the salt water coming in. And then on top of that, what Bruce is saying is now we've got maybe less rain coming, or less of it going into the ground anyway. Is that right?
that's true. And the other thing we could say about groundwater recharge is it also is what powers our streams in the summer and fall. So for example, Soquel Creek is right behind us here, and all the water there right now is not storm water that we happened in last winter. Instead, it's all groundwater. So if you don't have recharge, you don't have groundwater for the fish, and the city of Santa Cruz doesn't have stream water for their residents to use.
So we walk by Bates Creek, which is just up in Soquel a little bit, and that's one of the major recharge areas for this basin. And usually you'd see a smaller amount in the summer, but now it's down to almost nothing. It's just there's a little bit of standing water in the creek, but that's pretty much it.
I checked Soquel Creek this morning, and the normal for Soquel Creek, the meeting, is 14 CFS, cubic feet per second, and it's down below but 3.5.
Oops.
So it's way down from where it needs to be. And as the summer goes on, the average goes down, and this will go down even faster. So it is conceivable that the stream could literally dry up this summer, which would kill all the fish that are in it. And that, unfortunately, is the future if we can't do things about this problem.
So I was going to ask how that affects the marine life and the fisheries that we have in this area here.
Well, certainly the fish that go inland to spawn, like the steelhead trout and the coho, they are the ones that are facing perhaps even extinction in the future if we can't somehow figure out how to solve these problems. But for those that live in the ocean all the time, the big problem there is ocean acidification. The thing that causes climate change is all of the gases that get burned and end up in the atmosphere, like carbon dioxide. And some of the carbon dioxide stays in the atmosphere, but about half of it ends up going back into the ocean, gets absorbed in the ocean. And when you mix water and carbon dioxide, it's called carbonic acid. And so that's going to acidify. Already the ocean is 30% more acid than it was 100 years ago. And,
And what does that mean? Is that good or bad?
that's a
or-
bad thing because just like when carbonic acid goes down into the ground into limestone and dissolves the limestone and creates caves, the same thing happens in the ocean with all the marine life that has shells. It dissolves the shells of corals and other marine animals that are the basis of the food chain. So if they can't exist, then the little fishes on top of them can't exist, and the bigger fishes on top of them can't exist, and all the way up to whales and so forth. So
And Bruce, what would it take to reverse acidification at this point? Is it possible, or is it really not that?
well,
possible?
the main thing is to stop making it worse. I mean, every year we add more carbon dioxide to the atmosphere, which ends up back in the ocean too. So that's the first thing to do, is to try and do things to stop that, which means we need to go away from carbon burning for everything. So coal, oil, natural gas, we need to stop using those for our energy. And then in the future, we can certainly talk about ways that we might take carbon dioxide out of the ocean and the atmosphere. But
it's not going to change very quickly.
it's not going to change very quickly.
Yeah.
We've been doing this
Yeah.
since like 1850 when the Industrial Revolution started.
And now we have developing countries. It's not just the
Right.
Western world. Now we have China and India and Brazil.
Yeah. For each one of us here in a developed country, here, Canada, Europe, so forth, there are 5 people in the rest of the world, in the developing countries, and they all want to live like us. They all want to have cars, they want to have television sets, they want to have iPhones, they want to have, heat in their homes. And so they want to rise up to where we are now. And if that happens, it's just going to be 5 times worse than we have it right now. So it's frightening to look at.
So, how does global warming or climate change affect the plant world that we have around here?
Well, let me talk about redwoods first of all.
Okay.
The county did a study a few years ago by the U.S. Geological Survey, and one of the things they did was interesting. They divide up the county in little areas, and they figured out what's the climate in each one. Is this one a little wetter than this one? Is this one a little hotter than that one? And they also looked at which ones were redwoods growing on, so they could therefore figure out which areas had the climate that redwoods like. They then ran that forward to the end of the century and said, okay, what is this area, will its climate be in 100 years? And is that one of those areas that redwoods are living in? And they found most of the areas in the county where redwoods grow now will no longer be habitat for redwoods in the future. It doesn't mean that redwoods will instantly fall over and die, but it means probably new ones that might grow and replace the ones over the years probably won't have the ability to do that. They will.
And what's an explanation or a set of explanations for that? Why wouldn't they grow very well anymore?
Well, it's the evaporation effect I mentioned before. That means that the water that's in the soil moisture, is just not going to be there as much. In fact, there's a study that was done last month by some scientists, and they were predicting that by the end of the century, the amount of water, both a foot down from the ground surface, that would be water that's used by annual plants that grow for a year and then die and then get replaced, and then the water down 6 or 7 feet, and that would be water used by perennials like trees and bushes. Both of them is going to be down way, way, way below what they have been in the past. So there may not be enough water for most plants to live here, the ones that we're familiar with.
So then if we lose those redwoods or we have less cover, one of the things that is that then
that increases the drying as
right,
well.
There's not a place for the water to seep into the ground because
Right.
we have this clay soil here and it has to have time to seep down, right?
Right.
So if you lose some of the cover and the mulch that's created by all that, it dries out even more, and that's what you're talking about with this evaporation. Right?
And again, that's the bottom of the food chain. So all the plants that die off, they have animals that perhaps use them now for food or cover, and they won't be able to use them for food and cover in the future, and so they may not be able to survive here. So it's this leverage thing.
Yeah.
One of the redwood societies did some research. They hired some scientists to do some research. And in their research, they looked at the fog, which is one of the things that the redwoods depend on for a good chunk of their moisture. They don't get it all from the ground. They get a lot from the fog. And they're predicting that in the future it'll be like 35% less fog. So that's not a good sign for the redwoods either, that they're losing water from the ground, and they're also losing the water they get from the sky.
And the reduction in fog, is that connected to climate change?
Yes, it's
or-
climate change again.
Okay.
It's the warming causes that to be lower.
All right. Good.
So Bruce, if we try to think about what the effect's going to be on some of the people in Santa Cruz from these changes that you're talking about, we think about some of the groups that are here. We have people that live in cities, we have people that live out in the countryside, we have agriculture to some degree, or some nurseries,
Fisheries.
So could we talk a little bit about how some of these people are going to be affected? And maybe one place to start is, again, where we've been sort of looking at this, is Mid-County has to have drinking water, and if we're going to have an increased population, we've got more people, we have to have them somehow. We're having to reduce how much water we are using every year, and yet we have more people coming. So how's that going to work?
Well, just like if a cup has less water in it, that means there's less to go around. And I think people here are already starting to learn to do with less. The response to the drought we've had so far has been very encouraging. But if this continues in the future, and my feeling is that probably that's the case, is we'll get more droughts like this. They'll happen more frequently, and they'll be more intense than this one. And if that happens, it means that we need to live on a smaller amount of water, a smaller budget of water than we have in the past.
So Bruce, if we look at the agricultural sector for a minute, and there's a lot of that down in Watsonville and Pajaro Valley, there's some of it here, how are these changes going to affect agriculture?
Well, agriculture as well is going to have to learn to live with less water. The predictions is that soil moisture will be drastically decreased in the future. So, and already there's saltwater intrusion in the main agriculture area, which is Pajaro. So, they're already asking agriculture to cut back to solve the saltwater intrusion problem they have. And if, in addition to that, there's less moisture in the soil to start with, it's a double whammy. And
so where are they going to get enough water to grow crops?
It's really going to be a challenge. I mean, strawberries are known to use a lot of water. It's like 2 acre-feet for every acre. Right. So that's like 2/3 of a million gallons per acre of strawberries. And there are other crops like apples that use less. So unfortunately, the basin, which originally was mostly apples, has migrated to strawberries, and maybe something to contemplate is moving back to crops that use
Take
less
water.
water. Yes.
Well, before it was apples, Watsonville area was a grain growing area.
Ah,
And
interesting.
so they
How things change, huh?
Yeah. Yes.
But anyway, people will have to think about being smarter about their use. People in agriculture, certainly in the Central Valley, use a lot of flood irrigation. They literally take a field and flood it with water. Of course, a lot of it evaporates. Some of it soaks in, and that's how they do it. But much better would be to use drip irrigation, because you can get the same amount of water to the roots, but put less water into the system to make that happen. So there are things that can be looked at, and agriculture is, just like the rest of us, going to have to be clever and forward-looking to make it work here.
So, and if we think about people coming into the county, if we think about that somehow the county has to accommodate more buildings, more people living in this area, how is that going to take place when we're all trying to shrink down the amount that we use currently? And now you're talking about some things that mean that we have to have even more of a water supply, which we don't seem to have.
Right. Well, you're only going to add new things if the people that are here already decrease even more than they had to decrease to solve the problems we have. Okay, so you have to divide it up into more pieces.
So if you're going to move into the county, we're going to go from 50 gallons per person per day
to 40
gallons
yes.
per person per day in order to let you come move into the county.
Or we may have to go to 40 to solve the problems we have today.
That's right.
And he moves in and we have to go to 30.
Yeah.
So that's the kind of thing we're looking at.
So we were likening this to, we've been thinking about trying to have enough water, and we've just, through conservation and through looking at some new supply, there's the possibility of balancing out Soquel area using the right amount rather than too much, so that it's used for a bunch of time.
What you can think of as taking a home and doing some remodeling on it, fixing it up so it's better. And with this, it means that this home that you're remodeling is going down the hill, and every day you show up to work on it, it's 50 feet further down the hill, and
we're trying to build on
things
it.
that were like this have gotten bent or twisted, and so just keeping up with those changes is going to be hard enough and actually making improvements at the same time is particularly challenging.
Well, reminds me of Alice in Wonderland. What
Right.
was that?
The saying is, the Red Queen says to Alice, in this world, you have to run as fast as you can to stay exactly where you are, and if you want to make progress, you have to run twice as fast as that.
Twice as fast as you can.
Yes, as you can, exactly. So we're facing a challenging future, so it's going to require, it's certainly true that the saying about the drought is going to be true of the future. We're all in this together. We all have to work on the solutions together.
Okay. What can the regular person do?
Well, for water, there's lots of things. People are already doing them. They're getting rid of their lawns, which use a lot of water, and other than being green, they don't provide much value. And so replacing their high-flow toilets with low-flow toilets, using low-flow shower heads, using gray water from washing machines to water their landscape, putting in cisterns to collect rainwater off the roof. There are lots of things people can do, and in the future we'll have to make sure that that just happens more and more. Well, it is certainly true that in figuring out how to solve these problems we're in, we need to look at other organizations, other countries that have faced similar problems and tried various things and found what's worked for them.
Mm-hmm.
So one is Australia. They had over a 10-year drought, and some of the predictions for here is we'll get droughts at least, maybe even longer than that. And they had to change things. They changed the way people work. They changed the way the whole water system works, how they allocate water, how they pay for water, and we'll have to do things like here. Another country that's done quite well with this is Israel. Mm-hmm. They invented desal. They invented drip irrigation, and so they have a nice civilization. People have a nice quality of life, but they use like 40 gallons a person, including agriculture.
Wow, including agriculture.
So
Compared to the average American uses
it's over 100.
135
It's like
gallons.
105 here in California, and I think across the country it's even higher than yes, higher than that. So we're doing good here in the county, but we need to do better because the challenge is on us. This county is one of two in the state that neither imports nor export water. So we can't expect the cavalry to come over the hill and give us the water to solve our problems. We're going to have to fix the problem ourselves.
Yeah, and we're going to need to create some more water besides what we get from the rain,
Right.
and potentially from the San Lorenzo River as well, right? So we're going to need to.
Absolutely.
That means wastewater recycling or desalinization,
Or both. And in the future, we may need to do a little bit of everything to solve this problem.
Yeah,
Because
you were saying last night we need all the water we can get
We need all the water we can
because
get.
this slippery slope is happening. That's what scared me when I listened to Bruce. Is it's not just that we can fix where we have been, but what's coming is creating that slippery slope we were talking about, and so we have to have more water than we can think about just to be able to address
an example
those.
is sea level rise.
Yeah.
Sea level is going to rise about 4.5 feet, and that means if nothing else happens, then there'll be more saltwater intrusion because the salt water will be higher and push inland even faster. So it means we need to increase as the saltwater goes up, we need to increase the inland water as well.
Right.
And that means we need to put water in the ground simply to stop things from getting worse with saltwater intrusion.
Because otherwise we lose the water that we did have.
We lose the water we did
Yeah.
have, exactly so.